Hello everyone, my name is Sumitra Singh from the Department of Electronics and Computer Science at Sri Allah Tiwari College of Engineering. In this presentation, I will share my learning journey during my Emertxe internship and how I implemented a simulated home automation system using Arduino, PicsimLab, and the Blynk IoT application. This project demonstrates the integration of programming skills with IoT concepts to control and monitor a smart home system. The internship focused on strengthening my understanding of C and C++ programming while applying these skills to embedded systems and IoT. It lasted for 4 weeks, during which I worked on coding with Arduino IDE, simulating systems in PicsimLab, and implementing IoT interfaces via the Blynk mobile app. The main objective was to learn to connect software logic, sensor data, and IoT platforms to build a functional smart home automation system. During the first phase, I practiced core C and C++ concepts, including data types, arrays, pointers, conditional statements, loops, functions, and structures. I also learned modular programming, file handling, and serial communication, which are essential for embedded systems. For example, I used functions to separate sensor reading from device control, making the code modular and easier to debug. These concepts directly translated into Arduino coding, where I applied them to control LEDs, read sensors, and interface with the Blink app. The project title Home Automation using Arduino and Blink aims to create a simulated smart home system. It allows automatic and remote control of devices such as lights, heaters, coolers, and water vacs. The system monitors temperature, ambient light, and water levels, making decisions based on values. This simulation demonstrates how daily tasks in a smart home can be automated for efficiency, convenience, and safety, all while using virtual components and IoT interfaces. All hardware components like Arduino, Uno, LDR sensor, LM35 temperature sensor, LEDs, CLCD display, and the serial time were simulated using PicsimLab. The Arduino IDE was used for coding in C and C++. The Blink IoT app acted as the remote interface, allowing me to monitor sensor data and control devices directly from a smartphone. This setup helped me implement and test the entire automation workflow without needing physical hardware. The system architecture is a straightforward sensors such as LDR, LM35, and the serial time send data to the Arduino Uno. The Arduino processes the reading using program logic and outputs the result to the CLCD display and the Blink app. Through the app, I can monitor the system, control devices remotely, and receive alerts whenever sensors readings cross predefined thresholds. This architecture demonstrates the flow of data to processing to output in an IoT system. The project is divided into three functional modules. First, the garden lights control modules uses an LDR sensor to adjust LED brightness according to ambient light. Second, the temperature control system monitors room temperature using the LM35 sensor and operates the heater or cooler automatically. Finally, the water tank management module tracks water level and controls inlet and outlet valves, ensuring the tank never overflows or runs dry. Each module functions independently but follow the same Arduino to IoT flow. The garden light module uses the LDR sensor to measure ambient light intensity. When light level drops, such as during dusk, the system gradually increases the light LED brightness using PWM or pulse width modulation. This simulates automatic garden light turning on when it gets dark. The logic is simple but demonstrates how sensor data can be processed to control output devices effectively. The temperature control module uses the LM35 sensor to read the room temperature. The Arduino processes this analog data and displays it on the CLCD as well as on the Blynk app. If the temperature exceeds a threshold such as 35 degrees Celsius, the heater automatically switches off. This module shows how IoT can provide automated safety and comfort by integrating sensors and control logic with a remote interface. The water tank module uses a virtual serial tank to monitor water levels. Through serial communication, the Arduino reads the current water level and updates the CLCD and Blynk app. When the tank is full, the inlet valve is automatically turned off and a notification is sent to the app. This module highlights the use of threshold based logic and IoT for real time system monitoring and control. The Blynk app provides a user friendly interface for remote monitoring and control. I created one tab which consists water tank with virtual buttons and gauges and temperature control that shows real time readings from sensors. This allows me to switch devices on and off remotely. This dashboard style interface demonstrates the practical use of IoT for smart home automation. Now, let's see the project in action. The Arduino code runs. Now let's see the project in action. The Arduino code runs in PicsimLab, the simulating the sensor and devices. As the LDR detects low or high, depending on that, the intensity of the light changes. The LM35 measures temperature, triggering the heater or cooler based on the threshold. As you can see, the heater's value is due to heater being on, the temperature values increases. The moment it reaches 35, heater is off. For the water tank, we can see that when we on or off the water's outlet or inlet, the CLCD displays the inlet and outlet valves situation. The moment water tank value decreases than 2000, the inlet valve is on, although you off it. This is the stimulation of the project. In conclusion, I successfully built a fully simulated IoT home automation system. I integrated sensors, Arduino code, and the Blynk app to control and monitor devices efficiently. This internship helped me strengthen my C++ skills, understand embedded systems logic, and explore the practical implementation of IoT platform. Thank you for watching my presentation on home automation using Arduino and Blink.